Hello everyone. Now today we're going to discuss some of the problems on vector entities. The last class we discussed three problems on this. Now today we're going to discuss the two problems on this. Very important. Now these two problems are repeated in various university examinations. Now first problem, look at. Prove that del square r power n equal to n into n plus 1 r power n minus 2. Now this del square can be written as derivative of grade of r power n. R power n is a scalar quantity. Now first del apply on this should be have gradient. Now is a vector quantity. Now this vector quantity apply the del other del that we known as a die. That's why del square can be derivative of gradient of r power n, that is equal to n into n plus 1 r power n minus 2. The both statements are same. Okay. Now look at the solution. Now take for a position vector r bar equal to xi plus yj plus zk. Now r square equal to the magnitude of this is root of x square plus y square plus z square. Where we have r that, and r square is x square plus y square plus z square. Now this we have to derive it with respect to x. R square derivative is 2r, dou r by dou x equal to here x square derivative is 2x. Now these two terms are 0. Okay. Now dou r by dou x is, now 2 will cancel both sides. Now x by r. Now this we have to derive it with respect to y. Now 2r, dou r by dou y equal to 2y, 2 cancel, dou r by dou y equal to y by r. Now with respect to z derivation, now dou r by dou z equal to z by r. Next, to find for del square here, to find for del square, first apply the 1 del on r power n. Okay. Now that is grade of r power n. Now del r power n. Now del is I dou by dou x plus j dou by dou y plus k dou by dou z. Instead of writing for the 3 terms, I writing for only 1 term, taking of sigma. Then last step I will to split the sigma to the 3 terms for j and k. Now I wrote here only for I term. Now the similar terms we have to replace I by j and k and x by y and z. Okay. Now I take for only 1 term, r power n. Now this derivative with respect to x, r power n derivative n into r power n minus 1. Now dou r by dou x. Now dou r by dou x just we find x by r, that we applied here, x by r. Okay. Now r power n minus 1. Now 1 negative r will come here. Again minus 1 is n minus 2 into x. Okay. Now on this again apply for the double derivative, double operator of del. Now that is del square now. Okay, del square r power n is derivative of grade f. Now grade f just we find now, that we wrote here again del. Actually is a vector, right? Now this vector here del. And apply here del is I dou by dou x plus j dou by dou y plus k dou by dou z. Now I dot I is 1. Okay. Now derivative of gradient of r power n will give only scalar quantity, not for vector. Okay. Now here I dot I is 1, that is the first term. J dot and this j become 1. K dot in this k we have k. Okay. Now that we, instead of writing for a 3 terms, I write for only 1 term where I dot I is 1. Okay. N is a constant right outside. In this del operator we have dou by dou x of this term. Okay. It's a scalar quantity, not a vector. Okay. That's why we don't have I, j, k here. Now this we have to derive it with respect to x. Okay. Now in R we have x and x also x function. Now apply UV formula. Now this derivative n minus 2 into r power n minus 3. Now into dou r by dou x is as it is, plus first term is as it is. Now x derivative is 1. Now dou r by dou x is x by r, that we have to apply here. Now r power becomes here n minus 3, here 1 r power n minus 4, x into x square plus r power n minus 3. Okay. Now this is a term for only x. Now this same terms you can split for x, y, z. Okay, now this term we have for x, we have for y, we have for z. Okay, now in that n minus 2 r power n minus 4 is common, that I common it. For x we have x square, for y y square, right? For z here z square, no? That's why x square plus y square plus z square. Now this is the term we have for x is r power n minus 2, for y n r power n minus 2, for z r power n minus 2. The total we have 3 r power n minus 2. Okay. Now x square plus y square plus z square is r square. Now that I applied here. Now here r power becomes r power n minus 2 plus 3r power n minus 2. In both term r power n minus 2 common. Then here we remaining n minus 2, here plus 3. Now it becomes n plus 1. Now is n into n plus 1 into r power n minus 2. Okay. Is del square r power n. Now the first problem. Now look at the second one. Show that del square f of r equal to d square f by dr square plus 2 by r into df by dr. Otherwise we wrote like this also, rotation f double dash of r plus 2 by r into f dash of r, where r is a position vector xi plus yj plus zk. R square equal to x square plus y square plus z square, that we discussed for the previous one. Okay. Now same relation we are going to use it here. Dou r by dou x is x by r, dou r by dou y is y by r, dou r by dou z is z by r. That way relation we are going to use. Now this we may use other rotation. That here I wrote del of f of r equal to same relation. It can be written as f of r is a scalar function. R is a scalar, therefore f of r also a scalar function. Now del apply on a scalar is a grade. Okay, now is a vector. Now again del applied is a div. That's why div grade of f of r equal to f double dash of r into 2 by r into f of r. Now first find for this grade of f of r. Now sigma. Here del we have I dou by dou x plus j dou by dou y plus k dou by dou z. Instead of writing for 3 terms, I wrote for only 1 term using of sigma. Now after getting this, again I split for j and k. Okay, I wrote for I here dou by dou x into f of r. Now derive this dou f by dou r into dou r by dou x. Now chain rule we are applied here. Now dou r by dou x is x by r. Okay, I into f of r into x by r. Now take it for del square, that is div grade f of r. Del dot this function is a grade. Del dot this term. Okay. Now here I dou by dou x plus j dou by dou y plus k dou by dou z we have. Now to apply the dot product, we have multiplication of I dot I is 1, right? Now remaining j dot j, k dot k. We don't wrote that, only write for first term I dot I1, then I we have dou by dou x, that you have to apply for this function. Dou by dou x of dash of r into x by r. Now here we need to apply here f dash of r having x term, x we have x function and r we have x function. Okay. Now is u by v formula. Now u by v formula is now this derivative into v minus v as it is into dou r by dou x, v derivative by v square. Okay. Now the u we have again two functions, right? We have again u we have again two functions. There we need to apply uv formula. Okay. For that uv formula is u dash v plus v dash u. Now this derivative is f double dash of r into again r derivative dou r by dou x into x u dash v plus v dash. This derivative x derivative is 1 into v as t u dash of r. Okay. Now u dash, in u dash we have again uv formula, v as t is for u by v minus now v dash dou r by dou x, u is as it is by v square. Okay. Now the same rotation we have here. Now in this we are going to apply dou r by dou x is x by r. Here also we have dou r by dou x, x by r. Apply that. See, r, here x by r, multiply with the r, f double dash of r dot r into x by r into x plus r into f dash of r minus f dash of r into x into this term is x by r. Okay, now this x into x is x square here, here also x into x is x square. That I will go to write in the next step. Sigma x square f double dash of r plus r f dash of r minus f dash of r into x square by r square. Now this r square is split for each term. Okay, now r square here r square, 1 r will cancel, we have 1 by r, and here r by r square, r cube. Okay, now but this is a term for only x, right? Now when you split the sigma, you can have y and z. Okay, now f double dash of r by r square common. Now sigma x square we have here. Now we don't have a x here, but the same term we have for x, we have for y, we have for z. That's why we have same terms have 3 times, right? That's why 3 1 by r f dash of r minus f dash of r by r cube into sigma x square. Okay, now for sigma x square we have for x square and y square and z square, right? The sigma x, in this x we have for y and z, that split that sigma x square plus y square plus z square. Now this term become r square, right? Is r square, right? Now that I substitute here r square. Now similarly you can apply here r square. Okay, now r square will cancel here. Here also r square cancel, we remaining 1 r in denominator. Okay, f double dash of r plus f dash of r common, we remaining at 3 by r minus 1 by r. Okay, 3 by r minus 1 by r is 2 by r. Del square f of r equal to f double dash of r plus 2 by r into f dash of r. Okay, now these are the 2 problems on the identities. Next class I will going to give some more problems on these.